Professor Belfrost's science class is back.
Hi, welcome back to my class. And today, actually, I'm not very well, and I'll give you another lesson about mathematics too. Maybe this will be not very long. Yeah, we will finish up our prerequisite on algebra lesson. I mean, chapter today, and do some quick revision on it. So let's review our last lesson. So first point is that a polynomial is basically just a sum of or difference of terms which consisting of variable raised to a non-negative integer power, which can be written in the form as a n x power of n plus blah 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 plus a2 times x squared plus a1x plus a0. Second point, a number multiplied by a variable raised to an exponent is called coefficient, and its product is a term of polynomial. If a term does not contain a variable, it is called a constant, and we can find the degree of a polynomial by identifying the highest power of the variable that occurs in the polynomial. The term with the highest degree is called the leading term because it is usually written first. The coefficient of the leading term is called the leading coefficient. There are many possible operations with polynomials, such as addition and subtraction, multiplication, and for binomial there is what called FOIL method. Okay, so factorization and even more. A perfect square trinomial is when a binomial is squared. The result is the first term square added to the product of both terms and the last term square. The difference of square occurs when we multiply a binomial by another binomial with the same terms by the opposite signs, causing the outer and inner terms to cancel each other. Polynomials can be factored by first finding the greatest common factor, GCF. Some polynomials cannot be factored, and this is called a prime trinomial. Last point, sum of cubes can be factored into a binomial and a trinomial. Okay, done. Now let's move to our discussion today. Okay. So today we'll discuss about rational expression. Yeah. So what is a rational expression? Rational expression is actually just quotient of two polynomial expressions. We can apply the properties of fractions to rational expressions, such as simplifying the expressions by cancelling common factors from the numerator and denominator. To do this, we first need to factor both the numerator and denominator, and then can cancel out any common factors that we see. Quick example. So we have ratio expressions. So the numerator is x squared plus 8x plus 16, while the denominator is x squared plus 11x plus 28. So let's rewrite this expression in the factor form, which now we factor the numerator to be x plus 4 squared, and then the denominator become x plus 4 times x plus 7. We can then simplify the expressions by cancelling the common factor, which here is x plus 4. So we obtain x plus 4 over x plus 7. If we were given two rational expressions and asked to multiply them, then follow the steps. First, factor the numerator and denominator. The second step is multiply the numerators. Third step, multiply the denominators, and then we can just simplify that. Quick example, multiply the rational expressions and show the product in the simplest form. The expression is given in this slide. Okay, so to solve this, let's see if we can factor the numerator and denominator as the first step expect us to do. So for the first rational expression, the numerator will be factored as x plus 5 times x minus 1, and the numerator and the denominator, actually we can just factor out the constant to be 3 times x plus n, okay, because 3 and 18, the GCF is 3, okay. Whereas for the second expression, actually doesn't we don't need to do anything because it has been in the most simple the binomial, not trinomial. Okay, so after that we can just simplify it by multiplying all the numerators and denominators together to create just a single expression, a single rational expression, And then we cancel the like terms, which is in case x plus 5. Okay, this is the common form. This is the common term, common factor, I mean. Okay, and we get it, x minus 1, 2x minus 1 divided by 3 times x plus 6. Done. If we are given two rational expressions and we need to divide them, then follow these steps. There are 5 steps. First, rewrite as the first rational expression multiplied by the reciprocal of the second. Second, factor the numerators and denominators. Third, multiply the numerators. Four, multiply the denominators. And fifth step is just to simplify. Okay? Quick example. You divide the rational expressions and express the quotient in the simplest form. The expression is just so. Okay, I'm not ready. Okay, how to solve this? So first we need to rewrite it as multiplication. So we just need to the first expression times we just need to write it as the product of the first expression, no change, and with the second expression being the reciprocal. Okay, so we write it as 2x squared plus x minus 6 divided by x squared minus 1 times x squared plus 2x plus 1 divided by x squared minus 4. Then we just factor each expression. This time, each of these expression needed to be factored. Okay, so 2x squared plus x minus 6 to become 2x minus 3 times x plus 2, x squared minus 1 to become x plus 1, x minus 1, x squared plus 2x plus 1 to become x plus 1 squared, and x squared minus 4 will become x plus 2, x minus 2. Easy. Then we just need to multiply them and create a single rational expression, which is shown in the slide. Now let's see if we can find out the common factors here to be cancelled out, which is x plus 2 and x plus 1 here. So after we cancel out these common factors, we are left with these new expressions, which is 2x minus 3 times x plus 1 divided by x minus 1, x minus 2. Done. If we are given two rational expressions and we are asked to add or subtract them, then there is easy way. Just follow these 5 simple steps. First is factor the numerator and denominator. And step 2, find the LCD or least common divisor of the expressions. Which LCD is the smallest multiple that the denominators have in common in this case. Okay. Third, multiply the expressions by a 4 of 1 that changes the denominators to the LCD. 4, add or subtract the numerators. And 5 is simplify. Quick example for you. If we are asked to add the rational expressions 5 of x plus 6 over y, then first we have to find the LCD, which is in this case xy. Okay, and then we just need to multiply each expression by the appropriate of 1. By mean 1, I don't mean that you multiply it by 1, it will not make change, it will not make any difference, or it will not change anything. But instead, what I mean is that uh, please uh, multiply it with any conversion factor that will make it to be in LCD form. Okay, so because we need the denominator to be xy, so for 5 over x, we need to have another y, right? And for 6 over y, we need to have another x. So for 5 over x, we just need to multiply by y of y. And with 6 over y, we just need to multiply with x over x, okay? So we obtain the forest shown in the slide, and thus we have 5y over xy plus 6x over xy. And now we can just simply combine the expressions to be the sum 6x plus 5y over xy. Done. Next, if we are given a complex rational expression, we can just simplify it by following these steps. So there are actually just simple 6 steps. The step 1 is combine the expression in the numerator into a single rational expression by adding or subtracting. Second, combine the expressions in the denominator into a single rational expression by adding or subtracting. Third, rewrite as the numerator divided by the denominator. Fourth, rewrite as multiplication. Fifth, multiply. Sixth, simplify. Done. Quick example, simplify the expression shown in this slide. How to do that? Actually simple. First, we need to combine the expression in the numerator into one expression, which is y times x over x. Yeah, because x over x, it gives us 1, and plus 1 over x. Okay, so it gives us xy plus 1 over x. Now the numerator is a single rational expression, and we are done. So we can just make a single rational expression, which is xy plus 1 over x divided by x over y. Then we can rewrite this division in multiplication form, which is xy plus 1 divided by x times y over x. After that, we can just multiply it and it gives us y times xy plus 1 divided by x squared. Done. This is the lesson today. Very short, right? Now let's move to the let's practice session for today's lesson. So the first problem is simplify this rational expression. So in the slide, so how to do that? Actually, it is very simple. So first, we need to just factor the numerator and the denominator. So for the numerator, we can factor it as x plus 3 times x minus 3. For the denominator, we can factor it as x plus 3 times x plus 1. Then, what is the common factor here, which is x plus 3? Then we can cancel this common factor, and we are left with this expression, x minus 3 and x plus 1. So this is the most simple one, and we are done. Second problem, it is subtract the rational expression 6 over x squared plus 4x plus 4 minus 2 over x squared minus 4. So how to simplify this expression? So first we need to factor its expression, because we know x squared plus 4x plus 4 actually can be factored as x plus 2 squared, and x squared minus 4 is actually x plus 2 minus x plus 2 times x minus 1. So you can rewritten this expression as shown in the slide. Then we multiply each fraction to get the least common divisor, which is x plus 2 squared times x minus 2. And we can rewrite the expression in a new form. Then you just need to multiply them and apply the distributive property. I mean the minus sign, the negative sign. And then just subtract it, easy. So we are to obtain 4 times x minus 4 divided by x plus 2 squared x minus 2. Done. Number 3. Multiply the rational expressions and express the product in the simplest form. So we have two problems here, A and B. So just take a screenshot and okay, let's move to the solution. So to solve A, we need to factor the expressions to become in this form. Quite long and not ready for you. Then we can just simplify it by multiplying the terms on numerators and denominators, and then cancel the common factors. Can you see the common factors here? Yes, the common factors is 2d minus 5, 2d plus 5. Then we obtain d plus 5, d minus 5 divided by 5d minus 1, 5d plus 1. Done. Or if you want to make it in trinomial terms, it is okay. I don't mind, but I will leave it in factored form. Okay. For B, we can simplify the expression by first factorize the expressions to create this new expression, and then we multiply the terms on numerator and denominator, then cancel the common factors. Can you see the common factors? Yes, you're right. So there are x plus 10, 6x plus 5, and 3x plus 2. And we are left with the most simplified version, which is 6x minus 5 divided by 6x plus 5. Done. Number 4. For the following rational expression, simplify it. So we have two rational expressions to be simplified. Let's see the solution. So for A, the first one, simple. We just need to simplify the expressions on the numerator first, and it gives us the term c minus 1 3c plus 2 divided by c plus 1 c plus 2. Okay, after that, let's rewrite the complete expression in multiplication form, because previously is in division form. We cannot do anything if we are still in division form, and cancel all like terms or common factors. Okay, so we do this as shown in the slide, and we left the answer c minus 1 3c minus 2 divided by c plus 1 2c plus 1. Done. For to solve the problem on B point, first, we need to simplify the expression on the numerator to be 80 over 6a plus ab over 6a, okay? Because we need to find the LCD of the denominator. Then we can just sum it, okay? So the numerator become 18 plus ab divided by 6a. So this is just a single rational expression, and we are not done with the numerator, okay? Now let's move to the complete expression and express it in the multiplication form, and we can obtain it 18 plus AB over 4B. Done. Number 5. Brenda is placing tile on her bathroom floor, which area is 15x squared minus 8x minus 7 feet square. The area of one tile x squared minus 2x plus 1 feet square. Find out the number of tiles needed. So here's the solution. So the number of tiles needed is simply just the division of these two. Okay, this is the rational expression with x squared minus 8x minus 7 divided by x squared minus 2x plus 1. To simplify this, first let's factor the numerator and denominator out, and we have 50x plus 7 x minus 1 divided by x minus 1 squared. By cancelling the common factor here, which is x minus 1, we can obtain the number of tiles needed is 15x plus 7 divided by x minus 1. Done. So that's the practice. Now this is the exercise for you. Okay, so please take a screenshot. Also, I have provided you with the answer. So after doing the exercise by yourself, then check if you have done it correctly. Because this answer I have verified this answer before. Okay. Okay. Let's move to final review. So this is not just the review on this topic, but the whole chapter, the prerequisite on algebra chapter. Okay. Let's see if you still understood all of these questions. Okay. Okay, start from the problem. Number one, find out the GCF of 88a cubed b plus 4a squared b minus 1448 squared a squared. I'm a little tired. Okay, so here's the solution. So first find out the GCF, the coefficient. Yeah. So for the coefficient, the GCF is 4. For a term, the GCF is a squared. For b term, the GCF is 1. So the GCF of all the terms of the expression is just the multiplication, which is 4 times a squared times 1, which is 4a squared. Okay, actually we are done, but if we are asked to factor the expression, it's very easy, right? We just need to find out, we just need to factor out the 4a squared and find what terms are left for each terms of the polynomials. So we can rewrite it as 4a squared times 22ab plus b minus 36 if we are asked to do so. But in this problem, we are not asked to. Okay, so just left with 4a squared. You are done. Number two, factor the polynomial expressions. So there are 3 polynomial expressions here. Let's solve them one by one. For the first one, we need to find out the P and Q, which product is AC equals minus 216, and which sum is B equals 30. Yeah, maybe you need to write to create the table. I will not show the table here for you, but because mostly I used some white guess. Okay, after some trials, I found out that the P must be minus 6 and Q must be 36. We can verify this. So we can create this expression, 8a squared minus 6a plus 36a minus 27, and factor it as shown in the slide. And we are done. The new factor expression is 2a plus 9 times 4a minus 3. Okay, so that's for A. How about B? Yeah, for B, we only need to follow the rule that A cubed plus B cubed is equal A plus B times A squared minus AB plus B squared. And we need to know that here A is P and B is 6. So we obtain the expression in the factor form is to be the product of P plus 6 and P squared minus 6P plus 36. Done. To solve the problem C, first we need to find the GCF of the coefficients, which gives us 1, and then the GCF of the P term, which also gives us 1, and the GCF of the inner expression of P plus 3, which gives us P plus 3 to the power of 1/3. And the total GCF is P plus 3 to the power of 1/3. And by noting this, we can easily factor it as shown. Yeah, so P plus 3 to the power 1/3 times minus 5P minus 24. Number 3, the last one. Simplify this expression A and B. Okay, so to solve expression A, actually this is very simple. First, we need to factor its sub-expression in this rational expressions and change the division form into multiplication form. Then cancel out the common terms to simplify. So we are done. we have m plus 2, m plus 3 divided by 2m plus 1m minus 3 times 2m plus 1, 2m minus 3 divided by 2m minus 3, m plus 3. What is the common form? Which is 2m minus 3, 2m plus 1, and m plus 3. So we are left with m plus 2 divided by m minus 3. Done. To solve b, first we need to find the least common divisor of the numerator to create a single expression. Then just simplify it by changing the multiplication form into the division form into multiplication form. Okay, so you can just rewrite it as shown in the slide, and we can cancel the like terms, which is cd and c plus 2d here, and we are left with the answer, which is 1/6. So here a final exercise for you to revise yourself. I've provided the answer for you to check your solution after you give a try. Okay, that's done. Today here's a little quote for you. So Bill Clinton once said, "The price of doing the same old thing is far higher than the price of change." So keep doing, keep going, keep practicing. There's never any loss for you. Thanks for watching. Try to give a like, comment, and share this video. And I will be back every Tuesday and Thursday. So keep watching. Be thoughtful. Thank you and goodbye. See you all.